Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now going to be going through question number 10, which is the final question from this Pure Mathematics P1 International A-Level Edexcel exam from June 2022. Now, this question here is about this curve. It says figure 5 shows the sketch of the curve C, which is this curve over there, with the equation y equals 2 over 7x cubed plus 1 over 7x squared minus 5 over 2x plus k, where k is a constant. So this is a cubic curve, as you can see from its shape. It's a distinctive cubic curve shape. It says, for part A, it just simply says find dy dx. 2 marks. Okay, so that's pretty simple. All the terms are ready to be differentiated. Dy dx means you differentiate y with respect to x. Okay, so they're all ready to be differentiated. There's no need for us to modify anything. We can just simply go ahead and differentiate. As we know in P1, it's simply just multiply by the power and then subtract 1 from the power. So you multiply the coefficient by the power. So 3 times 2 over 7 is 6 over 7. So 6 over 7 x squared. Take 1 from the power. And then you can have 2 times 1 over 7, which is going to give you plus 2 over 7. And x to the power of 1, which I don't have to write the 1 there. That means x to the power of 1. And then the x term basically loses the x, and you're just left with the coefficient, because you have here 5 over 2 x to the power of 1. That's what's there. It's not written. And you multiply by the power, you get 5 over 2. If you take 1 from the power, you end up with getting x to the power of 0, which is equal to 1. So you don't write that down. And any constant, when you differentiate, becomes 0. So the k just disappears. It's not there. So that is dy dx. Very simple part A of the question. Okay, most people, that would be accessible to most students. Most students should have no problem with that whatsoever. Okay, then part B says the line L shown in figure 5, which is this line over here, the straight line, is a normal to the curve at the point A. So it's a normal to the curve at the point A, meaning it's perpendicular to the tangent at A. Now, at A, the tangent would be a line that just touches A, so it's going to be something like this, and it has the same gradient as A. It doesn't cut through the curve, it just brushes the curve at A. So basically, that what it means is it has the same gradient of the curve at A. The gradient of this tangent and the gradient of the curve at A is the same. Okay, that's what that means. Now, the line L is normal to the curve at A, meaning it's perpendicular to its tangent. That means its gradient is perpendicular to the gradient of the curve at A, because the normal and tangent are they are perpendicular. They meet at 90 degrees. Okay, so it says it's a normal to the curve C at the point A, and it has x coordinates negative 7 over 2. So we know that the coordinates of A, the x coordinate is negative 7 over 2. We don't know what the y coordinate is, okay, but we know that that's the x coordinate of A. Okay, then it says given that line L is also a tangent to the curve at the point B, show that the x coordinate of B is a solution to this equation here. So this line L, not only is it a normal to the curve at A, it is the tangent to the curve at B, which means that the gradient of the normal of this curve will be the same as the gradient of the point B. Okay, so if I want to find the x coordinate of B, what I can do is I can find the places where this curve has the same gradient as the normal to the curve at A, because the normal to the curve at A has the same gradient at as the point B, as a curve at point B. Okay, so if I can find the gradient of the curve at A, then use that to find the gradient of the normal at A, that will be equal to the gradient of the tangent at B. That will be equal to the gradient of the curve at B. And then I can use that in conjunction with my gradient formula to find what the coordinates of B are. Okay, so I can then form this equation which will help us do that. So basically what I need to do first is I need to find the gradient of the curve at A. So what I can say is that the gradient of the curve at A, the gradient of C at A, is going to be given by dy dx. Now remember, this is the gradient function. When you differentiate a function, that gives you what's called the gradient function, which is dy dx. Okay, when x equals x equals minus 7 over 2. So if I find dy dx when x equals minus 7 over 2, that's the gradient of c at a. That's the gradient of the curve at a. Okay, so if I replace the x in this equation with negative 7 over 2, it will tell me the gradient of the curve at the point A, because that's what the coordinates of the point A are on the curve. Okay, so if I can then first do that, so I'm going to say, so the gradient of the curve, which is the tangent to the curve at A, is going to be equal to 6 over 7 times, it was minus 7 over 2 squared, plus 2 over 7 times negative 7 over 2 minus 5 over 2, which gives me 6 over 7 times 49 over 4. This gives you minus 1 because they cancel out. You got plus times minus is minus. 2's cancel out, and you got minus 5 over 2. This cancels with that. That gives you 7 and 1. And this cancels with that. That gives you 3 and 2. So you're left with 21 over 2. So you got 21 over 2 minus 5 over 2 minus 1. That's going to be 16 over 2, which is 8 minus 1. So that's going to give you 7. Okay, so that's going to give you 7. So what we can say about this is that, I'll put that over there to save some space. So what I can say that is that the gradient of the tangent at A, let me just make that a bit neater. The gradient of the tangent at A, is equal to 7. Therefore, the gradient of the normal at A is equal to its negative reciprocal, which is 1 over 7, which is also equal to the gradient of the tangent at B, because the normal at A is also the same line is the tangent at B. So now what I can do is I can equate the gradient formula, okay, which is dy dx, to negative 1 over 7, and that will tell me the places on the curve where the gradient of the curve is equal to negative 1 over 7. So I'm going to say that at B, dy dx is equal to minus 1 over 7. So dy dx, remember, is 6 over 7x squared plus 2 over 7x minus 5 over 2, and that we have to make it equal to negative 1 over 7. If I solve that equation, or I start solving the equation, I should end up with this. That equation I get will be a solution to the x coordinate of B will be a solution to this equation. This should lead us to that equation. So I want to get rid of all the fractions. So I'm going to multiply both sides by the LCM of the denominators, which is 14. So I'll multiply this side by 14, and I'll multiply all of this side also by 14. So 14 times 6 over 7, the 7 and the 14 cancel, leave you with 2. 2 6s are 12, so you got 12x squared, and you got 14 times 2 over 7, that gives you plus 4x, because cancels, leave you 2. 2 times 2 is 4, and 14 times minus 5 over 2, 2 cancels with 14, leave you 7. 7 times minus 5 is negative 35, and minus 1 over 7 times 14 is negative 2. So now we're left with, see, we have to show this, so we got to have it say equals 0, so I have to add 2 to both sides. So I'm left with 12x squared plus 4x minus 35 plus 2 is negative 33 equals 0. So here we've shown very clearly all the steps how we ended up with the same equation they asked us to show. Okay, so that's part B done. All right, so a bit of thinking involved. Okay, first of all, you need to figure out what the gradient is at the point B by using the fact that the normal to the curve at A is the same as the tangent to the curve at B. So the normal at A, to find its gradient, you first find the tangent at A, it's negative reciprocal, so that will be the gradient of the tangent at B, and then you equate the gradient to that value to find the places on the curve where the curve has that gradient of negative 1 over 7. Okay, so there's part A and B done. Now I'm going to go on to part C. Now part C says, hence find the x coordinate of B, justifying your answer. So we've just deduced that this equation will tell us the places on the curve where the gradient of the curve is minus 1 over 7, and one of those points was B. So solving this equation will give us the coordinate of B. It will give us the x coordinate of B. Okay, so to solve this equation, we could try to factorize. It looks a bit difficult to factorize, but I'm just going to try anyway. But you know, we have to show some sort of steps. So either factorizing or completing the square or using the formula. Now personally, I think I would just go straight to, especially if I was short of time, go straight to completing the square. I wouldn't bother, sorry, go straight to using the formula here. I wouldn't bother trying to factorize this because it looks a bit complicated. But I'll show you that it probably can be done anyway. Let's see, 12 times negative 33. That gives you negative 396. So your product is equal to negative 396. And the sum has to be plus 4x. Two numbers multiplied to give you negative 396x squared, and the sum is plus 4x. So think about the numbers 396. Let's think about 396. Okay, now I know that 12 times 33 gave us 396. So I know that 11 definitely must be a factor of 396 because part of one of the factors is 33. So if I divide this by 11, that might be a good start. That gives me 36. So we have 11 times 36. I'll just put it up here. 11 times 36. Now, that gives us 396. Now, if I fiddle around with this a bit, supposing I take a factor of 2 from here and put it here, that will give me 22. And then divide this by 2, that gives me 18. Okay, 22 times 18 will give me 396, of course, because I've just you know, switched a factor around. So 22 times 18 gives us 396. Good. And we can see that that works because they have a difference between them of 4. So we want a positive 4x, so I'm going to put positive 22x and negative 18x. So now I can factorize this. In these two terms, the common factor is 2x. 2x times 6x is 12x squared. 2x times plus 11 is 22x, and 6x times minus 3 is 6x times minus 3 is negative 18x. So now I have my factors. We can just see minus 3 times plus 11 minus 33. It seems to work. So we got 2x minus 3 times 6x plus 11 equals 0. Okay, now then we can solve it. We can say that either 2x plus minus 3 equals 0. So either 2x minus 3 equals 0, so x equals 3 over 2, or 6x plus 11 equals 0, so x equals negative 11 over 6. Now, if you couldn't do this using factorizing, I mean, it's not that easy to do. I just made a bit of a guesstimate. I guessed that 11 was definitely a factor. We know it's a factor because 11 is a factor of 33. And 33 is a factor of the whole number, so 11 must also be a factor. And then I started with that, and then I just juggled around some factors. So I just multiplied by 2, this by 2, and divided that by 2, and I found my, you know, if you can't think like that, especially in exam, this is the last question, probably short of time, I would go straight for the formula. So this is one method which is fine. I'll show you another method using the formula. Okay, but you have to show the steps of factorizing. Okay, so for the factorizing method, for here, you have to show the fact that you use the formula. Now, you don't have to quote the formula, but you have to show that you used it. And you know the formula is minus b plus or minus b plus or minus the square root of b squared minus 4ac all over 2a. So you have minus b, which is minus 4, plus or minus the square root of b squared, which is 16, minus 4 times a, which is 12, times c, which is negative 33, all over 2 times a, which is 2 times 12. So that will give us our solutions. Showing that step is enough for you, and then writing the answers down. So let's make sure that we've got it correct. Minus 4, we'll start with the plus. The square root of 16 minus 4 times 12 times minus 33 all over 2 times 12. So that will give us 3 over 2. Okay, so that gives us 3 over 2, and the other solution it gives us is going to be hopefully negative 11 over 6. I'm just going to change this, put a negative, that's for the minus part, and you see it's negative 11 over 6. Same two answers, but using the formula. And what we have to justify the x coordinate of b. We've got 2 x coordinates. So there's 2 places, as we can see, where the gradient is the same as this. So if I was to draw a line the same as L, you can see that there's another place which has the same gradient. that's also a tangent at this point here. So this must be the negative 11 over 6 because the negative side, and this must be the 3 over 2. So we can say B, okay, has a positive x coordinate. Therefore, x must be 3 over 2. Okay, we can see very clearly B has a positive x coordinate, therefore x must be 3 over 2. So that's justifying your answer. Okay, so I guess you got 1 mark for doing all of this factorizing, and you get 1 mark for stating that x is positive, therefore that's why x equals 3 over 2. All right, so that's part C done. And now for part D. It says, given that the y-intercept of the line L is -1, find the value of k. All right, so that means this equation is y equals, remember, the gradient was -1 over 7. So you have -1 over 7x minus 1. Okay, y equals mx plus c. If you remember, y equals mx plus c, the equation of a straight line. The gradient is -1 over 7, and the y-intercept is -1. So this is the equation of the line. So we've got to find the value of k. Now, what I know is that this line and this curve meet in 2 places. Okay, so L and C meet at A and B. That's where they meet, 2 places. All right, so we know that at A, x equals -7 over 2. And at B, x equals 3 over 2. Now, we could use that fact for, either of these 2 facts to solve the equation. Because where they meet, if we solve these 2 equations simultaneously, we'll find the x coordinate of where they meet. Now, we already know the x coordinates of where they meet. So if I solve these 2 equations simultaneously, I have to solve them, substitute one into the other. So what I'm going to do is I'm going to replace the y here with what this y is. I'm going to replace the y with what that y is. All right, so you have 2 over 7 x cubed plus 1 over 7 x squared minus 5 over 2x plus k is equal to -1 over 7x minus 1. So the solution to this equation here will be, okay, that will be the where it will tell us where they meet. Now, we already know they meet at these 2 places. Now, x equals 3 over 2 is something that we calculated, and we can't be sure 100% that we're correct. We might have made a mistake somewhere, although solving this equation is pretty, can even check it in your calculator if you want to make sure that you've done it correctly. And we did it in 2 different ways, we got the answer. We can be pretty sure we're correct, but we were given this value of -7 over 2. So it would be better or more sensible to use x equals -7 over 2 to just, use something that you're 100% sure is correct, because they told us that's where they meet. Okay, so this would be a solution to this equation, as would that. But we want a solution that will give us, we want either of them will be fine. If you did it correctly, you get no problems. But it's always more sensible to use what's given rather than what's calculated if you have a choice. So what I'm going to do is I'm going to use -7 over 2. So I'll replace the x with -7 over 2. So I have -7 over 2 cubed plus 1 over 7 times -7 over 2 squared minus 5 over 2 times -7 over 2 plus k equals -1 over 7 times -7 over 2 minus 1. Okay, so this is going to give me, I have to cube this first. So let me just put this in my calculator. That will make life easier. So I'm going to put -7 over 2, press equals. Okay, and I'm going to, that's my answer now. So I'm just going to use that and put it inside this. So I'll put 2 over 7. Okay, times, well, I can just put recall a cubed. Oh, I can, in fact, I can just, no, not a, sorry. Answer, or times answer cubed. Times answer cubed. Okay. Plus, I'll have 1 over 7 times answer squared. Whoops, answer squared. And minus 5 over 2, okay, times answer The answer here was the last answer to the calculator, which is minus 7 over 2. Now that will give me minus 7 over 4. So that's minus 7 over 4 is equal to, now that's going to give you plus a half. Minus 7 over 4 plus k, sorry. I forgot the plus k there. Okay, plus k is equal to, now this is going to give you, the 7's cancel out, that's going to give you a half. That's going to be plus a half minus 1. So that's going to give you minus a half. So minus 7 over 4 plus k is equal to minus a half. So now what I can do is I can say therefore minus 7 over 4 plus a half, k equals minus a half plus 7 over 4. Okay, keep k positive. So k equals minus 7 over 4 plus a half. So that's going to give me, that's minus 2 over 4 plus 7 over 4. Okay, which is going to give you 5 over 4. So we can say therefore k is equal to 5 over 4. So there's our answer for this last part of the question. Now, if I had used 3 over 2, I should have got exactly the same answer. Okay, and that's what, that's one way you could check that your 3 over 2 is correct as well. But I prefer to use what was given rather than what was, calculated, just to be on the safe side. Okay, so, as I said, either of those two would have worked because we know that these intersect at two places. One is here, one is there. Okay, so there's the answer to the question, which is question number 10, part D. And that concludes the whole of this question number 10. And that also concludes the whole of this paper, which is a June 2022 Pure Mathematics P1 paper from Edexcel. Other questions from this particular paper can be found in the playlist that will appear in this region over here. Other questions from this topic, which is to do with differentiation. Okay, and there's actually a few different topics here: straight line graphs, differentiation. But differentiation I'll put over here for sure. I guess I'll just leave it in that one playlist. And you can also click on the link over here to subscribe to my channel if you haven't already done so. Please check out the description underneath the video. You'll see the description of the video. You'll find some links to other material that I have made from these units of P1, also other units from International A-Level Edexcel, and also from the IGCSE syllabus of Cambridge. If you have any questions you want to ask me, you're welcome to leave a comment, and I will try to get back to you as soon as possible. Thank you for watching, and see you soon.